Let's start with the last part. Now we will run a simulation to access the results and save nice images from a macro. A simulation would be the next step after generating structures, so we choose a flow simulation. Therefore, select Predict, FlowDict. And here from the pull-down menu, choose the first one, the Stokes-Brinkmann equation, and then click Edit. Again, to make sure that we will start the simulation with the same settings, though the build and default settings with the third icon on the bottom left here, then we are asked if we also want to use the build and default materials, which in this case makes no difference as our structure comes to have the build and default settings. I will click No. Then we close the dialog again and click Run. The results are shown in the result viewer, and we later will be interested in the permeability value here, but for the moment we just close it. Now open the session macro dialog again, the macro, session macro, and here we can also see that the macro execution and vary Python macro are GeoDict commands that can be recorded, so that you could also run a macro from another macro. But we only want to get the FlowDict solve Stokes command, and however we will not save it in a new macro with this command, but we will attach this command to our already existing workshop macro. As analyses like the flow simulation always happen on the currently loaded structure, and we want to run it on different fiber structures. Therefore, click Copy to Clipboard, and this will only copy the selected commands with the parameters, not prologue with the header, description, and variable section, so we can just take this command and append it to our existing structure generation macro. So after clicking Copy to Clipboard, move to the editor again, to our Workshop 3 macro, save it under a new name, with File, Save As, change it to Workshop 4, and again save it in your project folder and as a Python file. Then here in the macro, scroll right at the end of the macro, and by right-click and clicking Paste, or by pressing Ctrl V, paste the FlowDict command. Then we see here the FlowDict command and above the FlowDict parameters dictionary. The first line of this dictionary is the result file name, and of course we want to edit this name again, so the variable values are part of it. So write the F in front of the string and append underscore GDSVP in curly brackets and underscore GDFD in curly brackets. Now we can also change the description again. Scroll up to the beginning of the macro, and add in the first line of the description and once a flow simulation. Click Save and go back to the macro execution control. Click Refresh, highlight Workshop 4, and now we can see that the preview has changed to also containing the FlowDict command. And in the description panel, we find our new description text. Click on Parameters, and for the solid volume percentage, again enter 10, 40, 70, and for the fiber diameter, enter 10, 20, 30, as before. Couple the variables by selecting solid volume percentage for fiber diameter and click OK and run. Now 3 fiber structures are generated and permeability is computed for each of them. Of course, we already generated these 3 fiber structures, so we simply click Override for all 3 of them. So here, then override the second one, and permeability is solved. Then override the third one, and permeability is solved also for the third one. with the 70% Z1 percentage. And if we now look again in our project folder, we can see additionally to the fiber structure result the 3 solved structs result files and result folders. Now we want to access the simulation results, as each structure generation or simulation produces a single GDR file containing all result values. Therefore, we move back to the main GeoDict user interface, close the session macro dialog here, and open one of the FlowDict result files. Either here by clicking on File, Open Results, and then browsing for the result file, or you can also open result files and also structures and volume fields by drag and drop. So here if I take my file explorer and then move the Stokes 1010 GDR file by drag and drop to GeoDict, then there it is opened in the result viewer. So here all the results from the flow simulation are stored. We can see a nice report of the results, and here right at the top we find the permeability tensor. The first 2 columns are empty, as flow was only simulated in Z direction. Of course, we could change that either in the FlowDict user interface or directly in the parameters dictionary in our macro, if you wanted. For now, we are only interested in the permeability value in the bottom right, so in the 3rd column and the 3rd row, which would be position 3.3. Then we move to the Maps tab here, which is a subtab of the Results tab, and we find a list of key value pairs. And these keys we need to access the respective values. We want to have the permeability 3.3 value here, so we have to remember this key and that it is in the result map. With this knowledge, we go back to our Workshop 4 macro and save it under a new name. File, Save As, and now Workshop 5. First, we can change our description again. Simply add in the first line and returns permeability, and maybe we could change the first and to a comma. And then in the first line of our macro, add a new line with import string map. This imports the Python module string map, which will allow us to access string map files. As GeoDict result files basically are string maps, this is exactly what we need to access our flow simulation results. So now, scroll to the end of the macro, right below the FlowDict command. And here, while scrolling down, we can see the computation directions we mentioned earlier, here directly below the result file name. And here 1 means flow will be computed in this direction, and 0 means it is not computed. So if we wanted, we could also select the other 2 computation directions by changing the zeros to 1, but we just continue scrolling down till after the FlowDict command. We will store the GDR file in a variable, which we call GDR. And here we right away need the module string map, and there we need the command pass GDR. And in round braces, we must enter the result file name as a string. And therefore, to be sure we use the right result file name, we scroll up again here to the result file name in the FlowDict parameters dictionary, copy it, and then scroll down again and paste it inside the parentheses. We want to have only one value in the result file, and that is the permeability we've seen before. It will be a string, so we call the variable we will use for this value perm_string. Accessing the values in the string map works similar to accessing values in a Python dictionary, as we've seen in the gd_run command, with square brackets. And inside these brackets, we have to enter the right key. In this case, we want a value from the result map. So we write result map, then a colon, because now we are in the result for that map, And there we need the key permeability 3.3. So here we always first need the right map for us it's result map, and then the right key that we found in the result map. As we would like to have this value as a floating point number instead of a string, we simply transform it. The new variable we will call perm, and then we will use the Python command float, and in the parentheses we will enter perm string. Then we will use the API function again, GDMSG box, to see the obtained permeability after each simulation. We will enter a string and starting with an F in front of the string. At the quotation marks we enter for SVP equals curly brackets and inside GD underscore SVP. And diameter equals curly brackets GDFD. Permeability is curly brackets and inside we write perm colon dot 2e. As the permeability value is very small, we format it with the E syntax we saw before in the strings example. We will only show 2 decimal places in the message dialog. So finally save the macro again. Then move to the macro execution control, click refresh. Then here the workshop 5 pie appears, highlighted. And now we see that the preview is gone. That is because we added Python syntax, which is not part of the GeoDict commands. Thus, workshop 5 is no simple macro anymore. Click parameters and enter again 10, 40, 70 for SVP and 10, 20, 30 for fiber diameter. Couple the variables again and click OK. Then we click Run. And now we have to overwrite not only the fiber structures, but also the corresponding floating results. And then our first message dialog appears. For SVP equals 10 and diameter equals 10, permeability is 3.15 E-11. Again, overwrite the second fiber structure and the second Stokes result. And then for SVP equals 40 and diameter equals 20, permeability is 2.65 E-12. Then overwrite the last fiber structure and the last result file. And the result for 70%, 31% and 30 micrometer fiber diameter is a permeability of 5.59 E-14. And in this way, any value from the result file can be accessed. You only need to know the right key and the right map, which you can find in the result file. We can not only access the result map, but also the input map, the log map, and the post map. Now in the last step, we also want to visualize our results and save nice images from our workshop macro. Therefore, we load one of the FlowDict result files again and move to the Flow Visualization tab. Here, click Load, and in the opening dialog, click OK. And the GeoDict visualization area collapsed the console again, so we have more space for visualization. We can see now the flow field and the structure. Here I have the structure with the 10% solid roller percentage and 10 micrometer fiber diameter. In this workshop, we only want to visualize the streamlines instead of the complete volume field. So above of the visualization area, you can find the visualization panel. If you uncheck the small box next to the volume field, you can only see the structure. Then check the Streamlines tab to visualize nice streamlines. Now we want to have nicer colors for our structure so that we can see our streamlines better. Therefore, select Color and Visibility here on the right of GeoDict. Then here the Color and Visibility panel unfolds. And as we can see here in the material legend on the left, our structure uses the material IDs 0 for the pore space, 1 for the first fiber type, 2 for the second fiber type, and 3 for the overlap in between. And the air with ID 0 is invisible as the corresponding checkbox here is not checked by default. We do not need to change the color here. But for the two fiber types and the overlap between, we need to change the color. Therefore, we click here on the color button and choose light gray. And also for the second fiber type, light gray, and for the overlap, also light gray. And now we cannot differentiate between the fiber types anymore, but there's more focus on the streamlines. GeoDict is a voxel-based program, so the structure consists of voxels, as we can see here, but the visualization would be even better if we would not see the single voxels anymore. Therefore, move to the Structure tab, and for Structure Renderer, select Smooth. Then you can see here that the surface became smooth. Rotate the structure until you like the camera angle. For example, I think this is now okay for me. So now we want to save the visualization as an image. Therefore, select File, Save Image As, and in this dialog check Preset and choose 640 x 480 VGA from the pull-down menu, and you can also see a preview of the preset in the GeoDict visualization area here. Then simply click OK, and let's call the image Streamlines. Now an image from our structure with streamlines is saved to our project folder. To record these steps, now open the Session Macro dialog again by selecting Macro, Session Macro. And this time we will need 3 commands, because first we need the command to load the volume field to be able to visualize the streamlines. Then we also need the Set View Status command, because all visualization settings are saved in this command. And finally, the third command we need is of course the Save 3D Image command. Press and hold Ctrl while selecting the needed commands with left mouse click. So here first the volume field, Set View Status, Save 3D Image. And as we want to append these commands to our workshop macro again, as we did with the Vlodic command, we click Copy to Clipboard. Open Workshop 5 and save it as Workshop 6. File Save As, Workshop 6.py, and last time make sure that this new macro is saved to the project folder and has the right file type. Then append the 3 commands from the clipboard to the end of the macro right beyond the message box command. In the Save 3D Image Parameters dictionary, we change the file name by adding an F in front, and we will add the variable values again with underscore and curly brackets. So here GDSVP underscore GTFD, again in curly brackets. And then we will scroll up to the Load Volume Field Parameters dictionary. And here, while scrolling up, you can see that there are lots of parameters for visualization. They can all be saved and changed in the macro. And here we have the Load Volume Field command. The volume field file itself has the same name for all Vlodic simulations, but the folder name corresponds to the result file name. Thus, changing the folder name is enough here. Add an F in front of the string, and here change the number of the solid volume percentage by entering curly brackets and inside GDSVP, and replace the fiber diameter by the variable in curly brackets GTFD. Then finally, scroll up to change the description again. Change the end to a comma and add and saves an image of the structure with streamlines. Save the file again and go back to the macro execution control. Then here we click refresh again, then highlight workshop 6. And here in the description, we see the final description of our macro. And then click on parameters. And again, insert 10, 40, 70 for solid volume percentage. And 10, 20, 30 fiber diameter. Choose solid volume percentage from the pull-down menu next to fiber diameter again. And then click OK. Click Run. And now, of course, the 3 structures are generated again, and variability is solved for each of them. And we've already generated all these structures and run the simulation, so we just have to click Override again. And here we have our message dialog. Just click OK. Again, override the second fiber structure and the second stocks result. Click OK in the message box and override, override. Click OK. Now every result was visualized and saved as an image. And in GeoDict, we see the visualization here of the last image with the 70% solid volume percentage and 30 micrometer fiber diameter. So now look in the project folder and find the 3 images of fiber structures and streamlines. Just open them in your image viewer. And here we see the first one for the 10% solid volume percentage and 10 micrometer fiber diameter. And then here the second one for the 40% solid volume percentage and 20 micrometer fiber diameter. And the last one we already saw in GeoDict with the 70% solid volume percentage and 30 micrometer diameter. And here on the workshop slide, you can also see all 3 next to each other. Observe how the velocity is much slower for higher solid volume percentages. For visualization, it would be even better if the legends would have the same scale for all images. That, of course, is possible in GeoDict. But how to do this, you can learn either in the visualization workshop or in the visualization user guide. And of course, you can reproduce every visualization by recording it to a Python macro. So after showing you how to access simulation results and save images from Python macros, in the end I want to briefly touch some advanced topics, and we will start with a nice FilterDict example. GeoDict comes with a simple application user interface to generate PowerPoint results with GeoPy. This is very useful, for example, if similar parameter studies are done often. Then a Python macro can generate a unified report of the results to analyze them and show them in a nice way. This slide and the following slide are generated by a Python macro, after another macro generated the corresponding parameter study. Fiber structures with varying fiber diameter proportions were generated, and the solid volume percentage stays the same for all structures, but the proportional percentage of the 2 fiber types varies. On the left, we start with the 100% thin fibers with 4 micrometer diameter and 0% of the thick fibers with 14 micrometer diameter. And then here, when we go to the right, we see more and more thick and less thin fibers, till we have 100% thick and 0% thin fibers. Then a FilterDict simulation was performed on each of the structures using a standard dust composition. On the images, we see that the structures are clipped halfway to see also some of the filter particles within the structure. This is only visualization. The structure, of course, is still there, but invisible. The thicker the fibers, the more particles go through, as we would expect. And the first part of the report generation macro was to save nice images of each structure and 2 plots that we will see in the next slide. So here we see the 2 plots that were generated with the macro. And the first plot displays pressure drop versus the fraction of thick fibers. So we see the higher the percentage of the thick fibers, the lower the pressure drop. The second plot shows the filter efficiency versus the particle diameter. One color for each of the different structures. So it starts here in the bottom with 10% thick fibers and 0% thin fibers. We have a higher efficiency the more thin and the less thick fibers are in the structure, as we have already seen in the visualization on the slide before. And how to generate PowerPoint reports you can learn in the GeoPy Advanced workshop or from the Automation and Scripting user guide. Finally, we briefly touch onto some advanced possibilities. First of all, you can also execute macros directly from the command line, including setting variable values, which is a powerful method to integrate GeoDict into your custom simulation and analysis pipelines. Furthermore, we have a set of GeoDict application program interface functions. We have already seen the GD1 command for the fiber structure generation and the FlowDict simulation, and the GD-MSG box. And these two could belong to the most important of these, but we also provide functions, for example, to directly access the voxel structure or simulation result fields, and for writing import geo filters for micro-CT images. We can find an overview of the API in the macro execution control. So here, move the macro execution control, and here on the bottom right, simply click GeoPy API Help. And here you see a nice overview of all the function names, and which arguments they need, and what is the return value, and finally here on the right, a short description. Additionally, you can find here the Automation Scripting user guide by clicking Help. It will not only explain the macro menu with all options, but also contains many examples on how to record macros, adding variables, using the string map, different variable types, and even all of the API functions have an example. You can also find a description of our simplified wrapper API for the PowerPoint report generation. Then we also ship a set of popular open source Python libraries, which are installed into the Python interpreter within GeoDict. This includes fast MATLAB-style numerics with the module NumPy that could, for example, be applied to volume fields as the flow field we've seen before. And then we have the powerful plotting library Map.lib, which is also introduced in the GeoPy Advanced workshop and allows to plot the results in a user-defined style. And of course, the Excel file generator XLSX writer to create Excel files from a macro. And of course, as already teased, the generation of PowerPoint reports from GeoDict results can be automated. The built-in Python interface, GeoPy, enables the automation of any kind of workflow. This significantly increases the productivity and the usage of GeoDict. Macros created in GeoDict can be adjusted by using the entire range of Python functionality. Any kind of GeoDict data can be accessed and processed from Python scripts. And finally, results can be exported directly into PowerPoint presentations. This enables, for example, the execution and individual presentation of parameter studies. And I want to conclude the workshop by summarizing what we have shown you. Now, hopefully you can record and playback macros through GeoDict to automate common and repetitive tasks. And also you can add variables to macros and run parameter studies to optimize your materials. And we showed you how to access any GeoDict result from a Python macro to summarize and compare simulation results. And we hope now that this will ultimately help to increase your productivity when working with GeoDict. And here in the last slide, the link here on the bottom leads to a great official Python tutorial to learn more about scripting. Thank you for your attention.